Hi fighters, I welcome you all to this session. So today we are going to see what does voltage divider rule and current divider rule mean. Very important rule for class 12th as well as 11th and for the first year engineering students. So let us see. First of all, we will make a circuit. Now voltage divider rule. Where does the voltage divide when the resistances are connected in series? So we will make a circuit where resistances are connected in series. So let us say the main supply is V and current is flowing from this side, and let's say this is resistance R1, this is resistance R2, and let's say the potential difference across this resistance R2 is V2. Now, according to voltage divider rule, the value of V2 can be found out as V equals to I into R using Ohm's law. So V equals to I2 into R2, right? Now in series of resistances, we know that the current flowing through both the resistances is same. So I, which is flowing through the circuit, into R2. Now, if the value of current is not given to us, then how to find it in terms of voltage source and resistance is given to us? Again, using the Ohm's law and substituting the value of I as V by R. So I equals to V by R. V is net voltage divided by R equivalent because it is resistance for the whole circuit. So R equivalent means R1 plus R2, right? So we get to know that potential difference across any resistance which is in series with the other resistance is equals to the net voltage given to us times that resistance value divided by net resistance, that is R1 plus R2. This is how to find the voltage of any given resistance in series. Now let us seek the current divider rule. Obviously the current will divide when the resistances are connected in parallel. So let us make a circuit where resistances are connected in parallel. Let's say this is R1, this is R2. Okay, now the current flowing through R1, let's say I1, and current flowing through R2 is I2, and the main current source is I, and the main voltage supply is V, let's say. Now current divider rule says the value of current through any resistance which is in parallel with the other resistance is found out as, let's say, I1. Using Ohm's law, we know that V1 divided by R1. Now in when the resistances are connected in series, the value of the main supply is always constant. So in this case, there is only V. So we will get V upon R1. Now, if the value of the main supply, that is V, it's not given to us, so we can find it using I and R only. So 1 by R1 as it is. The value of V using Ohm's law can be substituted as I into R. I is main supply of the current into R equivalent. In this case, R equivalent resistances are parallel. So R equivalent must be R1 times R2 divided by R1 plus R2 because distances are connected in series. Now we know that R1 cancel out R1 in both numerator and denominator, and we will get the value of current in any resistance which is in parallel with other resistance as the main supply of the current times the value of the other resistance which is in parallel with the given resistance divided by the sum of both the resistances. So this is what the both the rules say to us, and very important derivations, very important, very helpful, because when we are solving complex networks we have to frequently find the value of current through various arms of the circuit. So this is a very important results, we need to keep that in mind. So that's all for today. I will meet you in the next video.